That skill presents Simplifying Fractions 3. I would like to remind you yet again that you apply the same rules of simplifying fractions with algebraic expressions as you would do with simplifying fractions with constant numbers. To add and subtract, you need to find the least common denominator of the fractions and then rewrite each one of them on the least common denominator and then combine the like terms on the numerator and go on to simplify. To multiply or to simplify fractions, you should reduce or cross off common factors between the numerator and the denominator and then go on to multiply the remaining factors out. And to divide, you need to flip over the numerator and the denominator of the divisor, that's the second fraction on the division, and change the division to a multiplication. Let's review some problems. Let's say we have a 20a plus 10 all over 8a plus 4, and we need to simplify this fraction. Now if you look at the numerator, we have a 20a or a 20 times a, and then you have a positive 10. So you have two terms, and the common factor or the greatest common factor between 20a and 10 is 10. Because if you take a 10 out, you're still left with a 2 from the 20. 10 times 2 is 20. 2a plus 10 times what is 10? 10 times 1 is 10. Over, if you look at the denominator, there are two terms, 8a and a positive 4. And the greatest common factor between them is a 4. And if you take a 4 out from 8a, you're left with a 2a. Plus, if you take a 4 out of a 4, you're left with a 1 because 4 times 1 gives you 4. So this is what we have. And now that we see that there's a common factor between the numerator and the denominator, which is 2a plus 1, all of that, so we can cross off the common factor 2a plus 1 with the 2a plus 1 on the bottom, and that is equal to 10 over 4. 10 can be rewritten as 5 times 2 and 4 can be rewritten as 2 times 2. So if you cross off a 2 from the top with a 2 from the bottom, the final answer is going to be, you guessed it right, 5 seconds. 5 over 2. Let's try another one. Let's have a 16z squared minus 4 on the top all over 4z plus 2 whole square. That means the square is not just on the 2, it's on 4z plus 2. The parenthesis indicates that 4z plus 2 is being multiplied with 4z plus 2. Okay. Now this is going to be equal to, now if you look at the numerator 16z squared minus 4, does it look like you could play some trick on it? Remember, a square minus b square, that's equal to a plus b times a minus b. We have a 16z square, that means it's the square of 4z, 16 is the square of 4 and z square is the square of z. So we have a 4z square of all of that, that gives you 16z square, minus this 4 out here is the square of 2. So this is in the form of a square minus b square, where a is 4z. So we have a 4z here in place of a in our problem. And we have a 2. 2 is b. We have a 2 in place of b. So then we can go on to apply that formula, which we will do in the next step. Let's just rewrite this as 4z plus 2 whole square on the bottom. Now this is going to be equal to a plus b. What's a? 4z. 4z plus b. b is 2. Plus 2 times a minus b. 4z minus 2 on the top over 4z plus 2 whole square means, like I said, 4z plus 2 is being multiplied with itself. 4z plus 2, 4z plus 2. Now if you look at the numerator, it's got two factors. 4z plus 2, 4z minus 2. If you look at the denominator, the two factors are 4z plus 2. So at least you could cross off a 4z plus 2 on the bottom with a 4z plus 2 on the top. And the final answer is going to be 4z minus 2 over 4z plus 2. Shall we try another one? Let's have a m cubed or m raised to the third p square or p raised to the second plus m square p cubed all over m square minus p square is equal to, if you look at the numerator, it's got two terms. There's a m cubed here and there's a m square here. So at least m square can be taken out of the parentheses as the greatest common factor. In the same way, there's a p square here, there's a p cubed here, which means we can also take out a p square. Now what's left? If you take out a m square p square from m cubed p square, we only have a 1m left. Plus, in the same way on the second one, we only have a 1p left. Because if you multiply p with p square, you get p cubed. And then m squared has already been taken out. All over, now the denominator is the difference of two squares, so we can factorize that. M plus p is the common factor between the numerator and the denominator. Let's cross that off. And our final answer is going to be m squared p squared over m minus p. That's the simplified form of this.